How are we doing? This is Mr. Cruz, and we're going to have another lesson to follow up the lesson in class on bonding elements together to make compounds. So hopefully this will help kind of fill in the gaps. What you're looking at right now is a chart that shows the difference between an element and a compound. On the top, we have substances that are elements. So we have chlorine, which is a gas. It's found on the periodic table, and it actually is composed of two chlorine atoms combined, and it exists that way because that's the way it has to exist by itself as an element. Nitrogen gas, oxygen gas, and hydrogen gas are the same way. They call these diatomic molecules because they exist. Di means two, and basically this element is two atoms bonded together. So one molecule of hydrogen, for example, is H2. Okay? So these are elements because they're only made up of one type of atom. Nitrogen is only made up of nitrogen atoms stuck together. Chlorine gas is only made of chlorine atoms stuck together. If you think of a hunk of gold, it only contains atoms that are gold, and so that's an element, and that can be found on the periodic table. Now down below, we have examples of compounds. Compounds are two or more different types of atoms bonded together in a specific ratio. Now the ratio is indicated by the chemical formula, and I circled the chemical formulas here, and we look at the numbers that are subscripts. So if we look at nitrogen dioxide here, it's NO2, and the O2 refers to the two atoms of oxygen stuck to the one atom of nitrogen. For carbon dioxide, we have CO2. There's one carbon atom, and there are two oxygen atoms stuck to it. So these are compounds because they're made of different types of atoms bonded together in a specific ratio. So if I have a glass full of water, there might be millions of molecules in there, but if I could look at water in its simplest form, one molecule of water is two hydrogens and one oxygen bonded together. That means in the entire glass there's twice as many hydrogen atoms as there are oxygen atoms, but one simple molecule would look like this. So just looking at the chemical formula, we can determine how many atoms of each type of element are in a compound. So sodium sulfate. You can see here, this indicates that there's two atoms of sodium bonded with one atom of sulfur and four atoms of oxygen. Now in total, there are 7 atoms in one molecule of this compound. 2 sodiums, 4 oxygen atoms, that's 6, and then the 7th one is that one sodium atom. For glucose, which is sugar, type of sugar, it's C6H12O6, and so there are a total of 24 atoms in one molecule of sugar. Now, one little cube of sugar contains millions and billions of molecules, but in its simplest form, one molecule has 24 atoms, 6 carbons, 12 hydrogens, and 6 oxygens. So these numbers here, and we're going to look at water now, they're called subscripts. And in the example for water, the 2 indicates the number of hydrogens. And if there is no subscript after a symbol, then it's 1 understood. So no subscript indicates just one atom. So in a molecule of water, there are 3 atoms total, 2 hydrogens and 1 oxygen. Now the big question is, how and why do these atoms bond together to form compounds? And it has everything to do with what are called valence electrons. Valence electrons. And those are the number of electrons in the outer shell. And if you study the periodic table, there's a very simple pattern. Family 1 has one valence electron. So that means every single element or atom in this family only has one electron in the outer shell. If I diagrammed hydrogen, or if I diagrammed lithium or sodium or potassium, when I was finished diagramming it, that outer shell would only have one electron. Family 2 has two electrons in the outer shell. Now we skip the transition metals because they do lots of strange things. You'll learn about that later. Family 13 has three valence electrons. Family 14 has 4, 5, 6, 7, and then the noble gases has 8, or helium has 2, because there's only 2 electrons in helium. But what was unique about the noble gases is their outer energy level is full. So let's take a look at family 17. And I just erased it there so you can see. We have fluorine, chlorine, bromine, iodine, and that's all I have down here too, is these 4 types of atoms. So you can see in fluorine, this is family 17, so there's 7 valence electrons. So we can count them out. In fluorine, there's 2, 4, 6, 7 electrons in the outer shell. And remember, it's in period 2, so it only has 2 energy levels, and you can see there's 2 in the first, 1, 2, and then that outer energy level has 7. Now in chlorine, you have 3 energy levels. Here's chlorine. It's in period 3, so there's 3 energy levels. And first one's full, second one's full with 8, and the outer shell has 2, 4, 6, 7 energy levels. If we look at bromine, it has 1, 2, 3, 4 energy levels, but that outer shell has 7 electrons. And iodine has many energy levels, but once again, that outer shell has 2, 4, 6, 7 electrons. And so that's where we get this number 7. It's the number of valence electrons. So that is something that you need to know. And what happens with these valence electrons is they're either lost or gained, or electrons are shared, so elements can form compounds. And that's what we're going to learn next. So when atoms or elements form compounds, they do it in one of 2 ways. The first way we're going to talk about is called ionic bonds. Okay, and this is when one or more electrons from one atom is transferred to another atom. Now, the easy thing to remember is that this always occurs between metals and nonmetals. So you can look at the compound and decide, oh, there's a metal and there's a nonmetal in there. Then you know that it must be an ionic bond. Covalent bonds is the second way that atoms bond. And this is done when electrons are shared. And this happens between nonmetals. So if you look at a compound and it only has nonmetals in it, then you automatically know it's a covalent bond. Covalent bond is sharing electrons. Ionic bond is transferring electrons, where one atom takes an electron from another atom and kind of steals it as theirs. So why does this happen? Electrons are either shared or transferred so they can fill their outer energy level. The magic number is 8. Every single atom on the table wants to have its energy level, its outer energy level, full, or sometimes that means having 8 electrons. 8 electrons is kind of like the number of electrons that makes them stable, that makes the atom happy. Stable is the word that might be more proper. So 8's the magic number. So the first way we're going to talk about when atoms bond is an ionic bond. And in order for this to happen, the atoms have to either become a positive ion or a negative ion. Now, metals form positive ions. Metals lose electrons. Nonmetals become negative ions. They tend to take electrons. So they're kind of opposites. Metals lose electrons, they like to get rid of them. And nonmetals are like, hey, you don't want your electrons, we'll take them. And when this happens, when you lose an electron, you become a positive ion. Well, the question is why? Well, let's look here. If an atom has more protons than electrons, then it's positive. So here is an example where we have 2 protons and 1 electron. And so there's a surplus of protons, and so this would be a positively charged atom. Now, most atoms you learn have the same number of protons and electrons, but when they lose an electron, they become positive. And the nonmetals are the opposite. They tend to take electrons or gain electrons. And so in this example, you can see that this atom has an extra electron compared to protons. We have 2 protons and 3 electrons, so it gained a negative particle, so it became negatively charged. It's important to understand metals lose electrons to become positive. Nonmetals take electrons to become negative. Remember that. Now I'm going to show you a trick with the valence electrons. Remember, this is the chart that has the pattern for valence electrons. You can have a family 1 has 1 valence electron, family 2 has 2 valence electrons, family 13 has 3, 4, 5, 6, 7, and so on to 8. The noble gases are full with either 8 electrons, or helium has 2 in the outer shell, so its outer shell is full. So here's the trick. The question is, well, what ions does each element turn into? I'll show you the pattern. So family 1 they have 1 electron in their outer shell, and they tend to lose it. And if they lose 1 electron, they become +1 charged. Family 2 has 2 electrons in the outer shell. Now it's easier to lose the 2 than it is to gain 6, because it wants to have its outer energy level full like the noble gases. So it wants to get to 8, but if you lose these 2, the energy level inside is full, and so it tends to lose. Remember, metals lose electrons and they become +2 charged. So beryllium, magnesium, calcium, they form ions that are +2 charges. And see what boron's family does. They form ions that are +3 charges. Now the carbon family is sort of weird because they're right in the middle. 4 could either lose 4 or gain 4 to get 8, but they tend to do a lot of sharing of electrons. So you'll see a lot of compounds with carbon in it, for example, and their electrons are shared to bond to form compounds. And here's where it kind of gets tricky. The nitrogen family has 5 valence electrons. So it's not going to lose 5 because it's easier to gain 3. And if you gain 3 electrons to get that magic number of 8, you become -3 charged. Family 6, the oxygen family, has 6 valence electrons, and it wants to have 8, so it tends to gain 2 electrons, and it becomes a -2 ion. Family 17 has 7 valence electrons. It wants to have 8, so it tends to gain 1, and it becomes a -1 charged ion. So if you can follow this pattern, it's +1, +2, +3, and then you skip family 4, and then it's -3, -2, -1. You'll know what charge of an ion each element in that family will turn into. So you automatically know, oh, calcium, it's in family 2, it becomes a +2 ion. Let's see, what's another good one here? Sulfur, sulfur is in family 6, so it automatically forms, it's going to gain 2 electrons, so it's automatically going to form a -2 ion all the time. And that's an important pattern to see in the table. So let's look at some ionic bond examples here. These are easy to figure out because ionic bonds are always a metal with a non-metal. So you know, oh, lithium is over here, and I know fluorine is over here. Oh, metal, metal, non-metal, so I know it's ionic. And this picture shows what happened. Lithium has one valence electron, and it's trying to get rid of it. And fluorine has 7 valence electrons, and it says, I will take it. And now, fluorine gains an electron, becomes negative. Lithium lost an electron, becomes positive. And now they will bond together ionically because opposite charges attract. Here's an example with sodium. Sodium is in family 1 as well, so it has 1 valence electron, and it's trying to get rid of it. Chlorine is in family 7, so it needs 1 more valence electron to fill that energy level. And so chlorine says, I'll take it, and it takes that electron, and you can see it down here now, and it forms an ionic bond because when it gains an electron, it becomes negative. See the negative? And sodium lost an electron right here in the transfer, and it becomes a positive ion, and opposite charges attract. I also know that sodium's a metal, chlorine's a nonmetal, so it's an ionic bond. Now with magnesium oxide, this can also happen with multiple electrons. So magnesium, I'm going to use blue now, magnesium is in family 2, so it will form a +2 ion. Oxygen is in family 6, so it will form a -2 ion. And how that happens is magnesium has 2 valence electrons, 1, 2, and it says, I want to get rid of these. I have 2 electrons, I'm trying to lose them, so my shell underneath is full. And oxygen says, I need 2 electrons. I have 6 in my outer shell, I want 2 more. So oxygen takes those 2 electrons to fill its outer shell with 8. And when it does so, it becomes a negatively 2 charged ion. Magnesium loses 2 electrons when it transferred them over, and so it becomes a positively +2 ion, and then they bond together to form magnesium oxide. That's covalent bonding. Now, ionic bonding occurs between non-metals. So I can look at a chemical formula. Like right here, I have water, H2O. I know that hydrogen is a nonmetal. I know oxygen is a nonmetal, so this must be covalent. And both of these are examples of water bonding. This picture here that I'm going to circle in black actually maybe kind of shows what happens a little bit better. Here, hydrogen has 1 valence electron. And here's the second hydrogen atom with 1 valence electron, right here. And it wants to have a second electron in that outer shell. Hydrogen does. And oxygen it's in family 6, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. It wants 8. So this is a match made in heaven because oxygen and hydrogen can share their electrons to fill their outer energy levels. So what that means is the electrons will spend part of their time orbiting hydrogen and part of their time orbiting oxygen too. So what we have is kind of like a relationship where they're working together. These 2 electrons, one of them is hydrogens and one of them is oxygens, they're sharing them. Hydrogen's happy because it has 2 electrons in its outer shell. And since oxygen, it's doing the same thing over here, so this hydrogen's happy too. Okay, and then the oxygen's happy because it has 2, 4, 5, 6, 7, 8 electrons in its outer shell, so oxygen's happy. And it couldn't have happened unless they shared those electrons. So bonding is all about filling the outer energy level with 8 electrons, or 2 if it's hydrogen, because that only has the first energy level. 8's the magic number, and when those electrons are shared to make 8 or transferred ionically to make 8, then it will bond together. Looking at this water, these 2 electrons are being shared and these 2 are being shared. The green one's hydrogens, the yellow one is oxygens. And the same thing here. So to sum it up, ionic transfers electrons. Covalent shares electrons. Ionic occurs between metals and nonmetals. And covalent occurs between nonmetals only. But both of them are an effort to fill the outer shell. Okay, so these are the main concepts, and we'll talk more about this in class, but hopefully this video helped out. I'll see you tomorrow.